We're looking at question 5 on the homework set. So we're looking at products being manufactured in a factory in a two-step process. So it's as though the products are on a conveyor belt and step A acts on it and then step B acts on it, on each product. And if either one of step A or step B fails, then the product is considered defective. So the way you should look at this question is to look at both the steps as though they're acting simultaneously in the product, because you know that step A or step B will be executed regardless of whether the other one fails or not. So it's as though both of them are being run on the product at the same time, or at least together for each and every product, because they don't depend on the other's failure. So the conveyor belt doesn't stop if one fails and the other doesn't. So now we want to calculate the distribution of the number of products which go by until and including the first defective one. So that's mentioned in the question. So this is basically like a count of products until you find your first failure. So what random variable does this remind you of? You see that we're going to keep looking at products until a failure. So there's some probability of it failing, and we're going to keep waiting each and every turn until we find a defective product, and the moment we find a defective product, we stop. So what random variable does it remind you of from what you've seen in class? Well, it looks like a geometric, because every single turn you have a non-zero probability, maybe zero probability of failing, and you keep waiting until you find your first failure. So especially step A and step B, if you consider the number of executions of step A or step B until you find one failure of either of them, that's exactly a geometric, right? With parameter PA or PB. So every single turn you have 1 minus PA probability of not failing for step A, and you wait until your first failure, which comes with probability PA, and that looks like a geometric. So let's actually write down the two random variables corresponding to step A failing and step B failing, which are both geometrics as we just discussed. So XA is a geometric, probability PA, right? So you have it doesn't fail the first turn. I'm just saying this is like let's say this is what happens. So it's fine, it fails. It doesn't fail the second turn, doesn't fail the third product, and fails the fourth product. So this is how the sequence of failures and successes look, and the probability of this happening, of it failing in the fourth turn on the fourth product, is 1 minus PA times 1 minus PA times 1 minus PA times PA, right? So this is exactly a geometric. XP similarly is a geometric of PB. Now, what is X? X basically ends the moment either XA or XB ends. So the moment step A or step B fails, or either one of them fails, you know that at that point X will fail. So basically you're waiting for the first failure of either step A or step B. So what does that tell you intuitively in terms of math? Well, X is equal to the minimum, right? Because you're waiting for the smallest number to finish, and then you're going to say, okay, I'm done, right? So the random variable denoting the first, or the number until and including the first effect, is just the minimum of step A and step B failing, right? Now, what's the minimum of two geometrics? Let's look at it this way. So let's actually look at it without considering this equation directly. So the probability of either one of step A or step B failing is what? Okay, let's just consider the probability that step A and step B both don't fail. Step A, step B don't fail probability. Don't fail. What is this? So first, what's the probability that step A doesn't fail? 1 minus PA. What's the probability that step B doesn't fail? 1 minus PB, right? Because since step A and step B are independent, the probability that step A and step B don't fail is the product of the probability that step A doesn't fail and step B doesn't fail, right? So this is equal to 1 minus, or let's say plus PA PB. Whoops, that's annoying. PA PB minus PA minus PB. So what's the probability that the product is defective is at any given turn. So that is 1 minus probability that step A, comma B both don't fail, which is just what we calculated, right? If at least one of them fails, the probability that at least one of them fails is 1 minus the probability that both don't fail, which is equal to 1 minus this thing, which is equal to PA plus PB minus PA PB. Now what do we see? We see that at every single turn, the probability of X being defective is that, and the probability of it not being defective is 1 minus that. Now, does this remind you of any distribution? Well, it looks exactly like XA and XB, except this parameter inside has been changed. So it's quite literally the same thing with a different probability. So we see that X is now is distributed with a geometric distribution with parameter PA plus PB minus PA PB. That's it. And that is the distribution of X. So the minimum of two geometric distributions is a geometric distribution. So now we've computed the distribution of X. What is the expectation? What is the expectation? So as I hope you've calculated in question 3 on the homework set, the expectation of a geometric random variable is just 1 over the parameter, 1 over the probability of failure. So the expectation of X in this case is just 1 over PA plus PB minus PA PB. That's all. Which means you're done with question number 5. Now there are a few other ways to do it, and I'll discuss them shortly after removing the stuff on the screen. So another way of doing this would just be, let's define XA, XB. So let's say XA is geom with parameter PA, XB is a geom with parameter PB. Another way of doing this is actually to look at X is equal to min of XA, XB. Right? So now we can actually try to calculate the distribution of X directly. So what's the probability X is equal to K? This is equal to the probability, I just put a PR, okay, which is equal to the probability that XA is equal to K intersection XB is greater than equal to K plus, because these two are disjoint, XB is equal to K intersection XA is greater than K. So this is strictly greater than, because if it's greater than equal to, then we would have already considered the equal to case in both places in this particular, in the first expression. So this has to be strictly greater than, right? And since you know that XA and XB are independent, which is equal to probability of XA equal to K times probability of XB greater than equal to K plus probability of XB equal to K times probability of XA greater than equal to K. Nope, sorry, this is not greater than equal to, it's just greater than, strictly greater than K. So what is probability of X is equal to, XA is equal to K? So this is 1 minus PA to the K minus 1 times PA, right? And what is the probability that XB is greater than equal to K? That means you know that it fails at least 1 minus PA times PB, sorry, come on, Z. Okay, you know that it fails at least K minus 1 times. So that's what probability of X greater than equal to K means, because you know that it fails for the first K minus 1 times, and what happens after that is irrelevant, because whenever the event, or let's say whenever the step B fails, after that it doesn't matter. So when I said that it fails K minus 1 times, I meant it succeeds K minus 1 times. And then after that, it doesn't matter when it Actually, the step B actually fails because it's already greater than equal to and you're already within the event. Similarly, you have plus probability. Let's take that off. 1 minus PB to the K minus 1 times PB times. Now you know that XA has to fail definitely K times and maybe more. So you know 1 minus P to the K. Now if you work this out, you will end up getting the exact same thing, which is 1 minus PA minus PB plus PA/PB to the K minus 1 times PA plus PB minus PA/PB. This is exactly distributed, or X is, which implies, I'm just going to remove that. This implies that X is distributed exactly the same expression as a geometric, right? So X is distributed as a geom of PA plus PB minus PA/PB. And you get the same thing as otherwise. Alright, so these are two ways of doing the same thing. And I mean, definitely there are many other ways, but these are the two simplest ways to do it.